Imagine a cosmic clock that measures the entire lifespan of the universe, from its fiery birth to its cold, distant end. Our lives, even all of human history, are just a blink on this scale. So, let's speed things up, compressing the ages into something we can grasp. On our cosmic clock, 1 second equals 120 trillion years. With this, we can watch the universe's entire future unfold in moments. Why do this? Because we're curious. We want to know, what's next for everything? Understanding the universe's fate helps us understand our own place within it. By speeding up time, we can witness cosmic evolution play out before our eyes. The journey begins with the Big Bang, nearly 14 billion years ago. On our clock, that's a fraction of a second, all of human history is a microscopic blip. Our cosmic clock lets us become time travelers, venturing far beyond the familiar stars. We'll see a future so distant, the light from today's stars will have long faded. This isn't science fiction, it's a story told by physics, so hold on tight. We're about to witness the universe's entire future in the time it takes to watch this video. The clock is ticking. Let's begin. On our cosmic clock, 1 second equals 120 trillion years. Everything we know, the Sun, Earth, the Milky Way, exists in the stelliferous era, the era of stars. This is when the universe is filled with shining stars, making life possible. But on our clock, the entire age of stars lasts just 1 second. All the billions of years of stars forming, galaxies colliding, and planets orbiting, compressed into a fleeting sizzle. Our time, the time of starlight, is a brief, glorious flash in the vast darkness of cosmic time. Everything that's ever happened, from dinosaurs to space travel, fits within this 1 second burst. The universe is mostly not like this. For most of its existence, it will be darker, colder, and quieter. We are living in a special, privileged moment, a rare window of light. This perspective is humbling and inspiring. Our time is precious. The universe is burning through its hydrogen inheritance, and once it's gone for good. The era of stars is a finite resource. This realization urges us to appreciate the here and now, to look up at the night sky with wonder. We are witnesses to the universe's most spectacular show, a performance that lasts for just 1 cosmic second. Let's enjoy the view while it lasts. The show is already halfway over. As our first cosmic second ends, the universe changes. The lights go out. The last star, likely a dim red dwarf, exhausts its fuel and fades into a black dwarf. The stelliferous era concludes. The age of starlight is over. The universe enters a long twilight. Galaxies now graveyards of stellar remnants, black dwarfs, neutron stars, and black holes. The cosmos becomes a place of decay, not creation. Imagine the night sky. Total blackness, no constellations, no Milky Way. Any surviving civilization would struggle for energy in the encroaching cold. The vibrant cosmos gives way to something quiet and eternal. The laws of physics now orchestrate the slow disassembly of what remains. Our cosmic clock ticks past its first second, entering the first era of cosmic decay. The future is long, and very, very dark. The universe's story shifts from light to gravity and decay. The party is truly over. Welcome to the degenerate era, a universe of ghosts, white dwarfs and neutron stars. The crushed remains of dead stars now dominate. They no longer shine but slowly radiate away their heat, cooling over quadrillions of years. Galaxies drift apart. Planets orbit dead stars in eternal darkness. The universe is a cosmic cemetery, where the most dramatic events are rare collisions between stellar remnants. Occasionally, 2 white dwarfs collide, triggering a final flash of light. But these are separated by quintillions of years. Mostly, the degenerate era is defined by stillness and patience. This era lasts from 100 trillion to 10 to the power of 40 years. Our entire age of stars was a second. This era lasts for billions of seconds. The universe slowly dismantles its last solid objects. It is an age of profound patience. Even the most stable objects aren't eternal. White dwarfs, neutron stars, and black dwarfs are made of matter, but protons may eventually decay. If proton decay happens, it takes an unimaginably long time. perhaps 10 to the power of 37 years. Imagine a white dwarf, a planet-sized diamond, slowly dissolving as its protons decay. Over googles of years, it evaporates into a sea of subatomic particles. The universe begins to unravel, erasing its own past. Neutron stars, too, will dissolve. Everything that once made up stars, planets, and life will become a thin soup of particles. By the end of the degenerate era, the universe is almost empty. The only large objects left are black holes. The era of matter is over. The stage is set for gravity's final act. The universe is emptier and darker than ever. After the last proton decays, the universe enters the black hole era, the age of monsters. All normal matter is gone, only black holes remain, scattered across the void. These are gravity's final victors, stellar mass and supermassive black holes, the universe's ultimate tombs. The universe is now larger, colder, and emptier than ever. Black holes exist in isolated pockets, silent rulers of empty kingdoms. There is no light, no matter, no energy, just gravity and space-time. Time continues, but nothing happens. This era will last longer than any before, up to a Google years. On our cosmic clock, the black hole era spans trillions of seconds. It is an age so far removed from our experience, it challenges imagination. But even these giants are not eternal. They too must face their end. The universe waits for its final fireworks. Even black holes cannot last forever. Stephen Hawking discovered that black holes radiate energy, Hawking radiation. It's a slow leak, but over unimaginable timescales, black holes lose mass and evaporate. A stellar mass black hole takes 10 to the power of 67 years to vanish. Supermassive ones, up to a Google years. In their final moments, black holes release a brilliant flash of energy, a last firework in the darkness. Then, silence. The black hole is gone. One by one, every black hole meets this fate. With the death of the last black hole, the black hole era ends. The universe has erased its last complex structures. All that remains is a thin cold bath of radiation. The cosmos is ready for its final state. The end is near. After the last black hole evaporates, the universe enters the dark era. The cosmos is now almost perfectly empty, cold, and dark, a thin soup of fundamental particles drifting through the void. The temperature is just above absolute zero, dropping as the universe expands. Nothing happens. There is no change, no life, no thought. Time becomes meaningless. There are no events to mark its passage. The universe has reached maximum entropy, the ultimate heat death. This era lasts forever. The universe will expand and cool for all eternity. The grand story of cosmic evolution is over. All that remains is a silent, empty stage. The universe settles into an endless, peaceful night. We've journeyed to the end of time, watched stars burn out, matter dissolve, and black holes vanish. What does this epic story mean for us, here and now? Our lives and all of human history are a fleeting instant in the cosmic timeline. We live in an extraordinary temporary window, a universe alive and full of wonder. This knowledge should make us feel special. In a cosmos destined for darkness, we are part of the light. We are the universe's way of knowing itself, observing its beauty before it fades. The atoms in our bodies were forged in stars that will one day become cosmic ghosts. We are made of stardust, living in the age of stars, but the universe is full of mysteries. Dark energy, dark matter, and unknown forces could change this story. The future isn't set in stone. Science is a story of exploration. For now, we can look up at the night sky and feel awe. We are part of a grand cosmic story. Our role in this brief moment of light is to wonder, explore, and appreciate the universe we call home.